Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. We are going to finish up section 2.7. I know yesterday we looked at polynomial inequalities, which, like I said, most likely had a lot of review components for everybody. When we look at rational inequalities, I think this is something that is covered much less, if at all, in Algebra 2. So there's a good chance you're going to see some new topics here with this. So if you have a rational inequality, again, basically all that's saying is you have a polynomial in both your numerator and denominator. Now, that topic that we introduced in the last part of the section, critical points. Well, those were the zeros, but also your undefined values, or, again, the restriction. So there are going to be two types of critical points in this portion of the section. And when you have a restriction or undefined value, the one thing there is x can never equal it. So you don't even worry about whether or not this is less than or equal to or just less than. So first thing that we need to do, if you have something like this, 2x minus 7 over x minus 5 is less than or equal to 3. We need to get 0 on one side. So that's where, set it equal to 0. So basically all we're going to do is subtract the 3 over. So 2x minus 7 over x minus 5 minus 3. And again, I'm going to essentially say, we'll think of it as over 1. So minus 3 over 1. And so then we need to combine fractions. Well, in order to combine those fractions, we are going to need a common denominator. The next thing I'm going to also recommend, kind of going back to something we did in solving rationals way back in Chapter P, I am also going to recommend making that plus a negative. So 2x minus 7 over x minus 5 plus, when we distribute, negative 3x plus 15 over x minus 5, and that should be less than or equal to 0. Sorry about that. And then from here, now you can actually combine your fractions. So 2x plus negative 3x, negative x. Negative 7 plus 15 is 8 over x minus 5 is all less than or equal to 0. So our critical points. Well, here is where I like to actually say for this one, the note, x can never equal an undefined value. Well, right off the bat, for our critical points, I like to put x cannot equal 5. Now, that's our restriction from the denominator. Now, for the numerator, you're basically just looking at what is the solution. What would make negative x plus 8 equals 0? Well, add the x over, and the 0 is x equals 8. When I add that over, and I'll even, if you want, write that in. So those are our two critical points. Now what we're going to do is once again set up our sign chart. So for that, again, we work it exact same way, even though now instead of a factor times a factor, we have a factor essentially divided by a factor. All right, so our zeros are 5 and 8. So again, we need a value bigger than 8, between 5 and 8, and less than 5. There I'm going to use 0. So when you plug 0 in, well, 0 plus 8 is positive. 0 minus 5 is negative. If you take a positive divided by a negative, it's negative. Or simple, I have an odd number of negatives here. It's negative. Now, when I plug in 6, negative 6 plus 8, positive. 6 minus 5, positive. A positive times a positive, positive divided by a positive is positive. there aren't any negatives, obviously it's going to stay positive. And then when I plug in 9, negative 9 plus 8, negative. 9 minus 5 is positive. Again, either look at it as a negative divided by a positive is negative, or I have an odd number of negatives, so my end result is negative. Much like what we talked about in the first half. Most of the time, the signs will alternate, unless you have a multiplicity. Again, negative, positive, negative. That's kind of a way to check, hey, did I do the problem correctly? So we're looking for where it is less than or equal to 0. So the intervals where things are negative. Now, here is where you have to be careful. Again, we do not use 0 in setting up our interval. It goes to negative infinity because x cannot equal 5. Parenthesis. Around the negative infinity, it's always a parenthesis. Then our next interval starts at 8 and goes to positive infinity. Now, here is the key thing. Less than or equal to 0, I am going to use a bracket around the 8. So, when it's a 0, you do need to pay attention to that. When it's a restriction, it's automatically parentheses. So, there is an introductory example. Another one, if we have 1 over x minus 3 is less than or equal to 3 over 2x plus 1. Well, again, we need to move one of these. I think it's easier if you have the 0 on the right side, so I'm just going to move the 3 over 2x plus 1 over. So 1 over x minus 3 minus that. And that is less than or equal to 0. Well, so in terms of the steps, first set it equals 0. Now combine fractions. So again, we need to get our common denominator. 2x plus 1 for the first, x minus 3 for this one. And again, I am going to go ahead and make this plus a negative. So when I distribute 2x plus 1, now for right now, if you want to kind of until we get things combined, just put over LCD, I'm good with that. Negative 3x and then positive 9, again over our LCD. And so now when we combine 2x negative x, or excuse me, 2x plus negative 3x, negative x. I'm kind of answering it as I'm talking through it. 1 plus 9 is 10 over 2x plus 1, x minus 3. Do not multiply those out. I mean, I guess you could, but you make it a lot more work for yourself if you do. So, from here, our critical points. Well, if you want, I always like to start out with the restrictions. X cannot equal 3. X also cannot equal, subtract 1 divided by 2, negative a half. And then our 0, once again, if you add the x over, is 10. So, I will tell you, sign chart's going to be a little more complex for this one. For two reasons. One, there are 3 factors. So we have negative x plus 10. We have 2x plus 1. We also have x minus 3. All right, so from here, our first critical point's negative a half, then 3, then 10. All right, and this is, again, kind of that whole, okay, the reason why we actually like just looking at are things positive or negative. Well, when you have to start using an 11 here, plugging in, calculating it out also, because you now have division, just looking at positives and negatives is a very nice thing. So, if I plug negative 1 in, well, opposite of negative 1 is 1 plus 10 positive. 2 times negative 1 is negative 2 plus 1 negative. Negative 1 minus 3 is negative. Here is where I just, yes, technically you're taking a positive divided by a negative times a negative. Well, that becomes a positive divided by a positive. Positive, simplest thing. If you have an even number of negatives here, it's going to be positive. Now, when I plug 0 in, positive, positive, 0 minus 3 is negative. Odd number of negatives, negative. Again, basically it's a positive divided by what would be a negative. Positive divided by negative is negative. When I plug 4 in, negative 4 plus 10 is positive. 8 plus 1 is positive. 4 minus 3 is positive. Positive divided by positive. Again, anytime all the signs are positive, it's simple. All right, the 11. Negative 11 plus 10 is negative. 22 plus 1 is positive. 11 minus 3 is positive. A negative divided by a positive is negative. So, again, you can see signs alternate. We are looking for less than or equal to 0. So our two intervals are from negative 1/2 to 3. Now we come over here. These are both restrictions. Our other interval, 10 to infinity, because it's less than or equal to 0, bracket. So, like I said, you can see if there are 3 factors or 3 critical points, a little bit more complex because your sign chart has not only an extra row, but also an extra column. Still only have 2 intervals. All right, find the domain. Well, again, domain of this radical, square root of 64 minus 4x squared, because it's a square root. When it's asking us for the domain, it's basically saying, where is this greater than or equal to 0? Now, I know we've looked at questions very similar to this, I think in at least 2 examples already. This is where I think a sign chart is really helpful. Because when we factor this, well, the first thing I'm going to do is factor out a 4. Now, that's your GCF. Now, this is a difference of squares. 4 minus x, 4 plus x. Well, as far as our critical points go, we don't really care about the 4. Factoring it out just made it easier to work with. The 2 critical points are 4 and negative 4. Well, now, basically, when we set up our sign chart, 4 minus x, 4 plus x, we don't have any restrictions because it's, it's a radical. Negative 4, positive 4, and we need a number in between. We need a number larger than 4 and smaller than negative 4. So again, when you plug in 4 minus negative 5, positive. 4 plus negative 5 is negative. A positive times a negative is negative. Square roots can't be negative, so obviously this interval won't work. Plug 0 in, 4 minus 0 is positive. 4 plus 0 is positive. Positive times positive is positive. And then when you plug 5 in, 4 minus 5 is negative. 4 plus 5 is positive. Negative times a positive is negative. Again, because we are looking for square roots, the interval we only care about is where it's greater than or equal to 0. The interval starts at negative 4, it ends at positive 4 because it can be equal to, we use brackets. So this is even going over an example we've looked at, or something at least similar, earlier in the year, and now even using this concept of a sign chart for it as well. So that actually concludes both parts of section 2.7, and we are almost done with the second half of chapter 2 now.